And welcome back to the lessons. We're going to continue where we left off last time, which is in Module 4 of Practicum by Yandex. Looks like we're on local and global variables, so I'll start it here. So they give us this huge description of local and global variables here, which I think is too long. Basically, what you need to take away from this description is you can have two types of variables. There's variables that exist inside a function. So, for example, you have a function here, define dollars to rubles, and then they make a variable rubles, and so this would be a local variable, right? Then we also have variables that are outside of functions called global variables, like this one, for instance. And you can access this variable within this function, but you can't access this variable, which is inside this function, outside of the function, okay? And one of the things they make clear is if you have a uh, so basically, if you have a global variable called rubles here, right? And then down here, you're making a new variable called rubles. Potentially, if you return the wrong rubles here, like look, you're returning the global variable instead of the local variable, you could run into potential errors that you wouldn't normalize see because that's valid code. You can return a global variable from a function, but it won't necessarily be the local variable that you're trying to use. So here we did a calculation, we're trying to return this rubles, but we made a typo and we actually did rubles with an E, and that is an actual global variable in this code, so it gets an error, okay? So that's all this big description is. I'll run through it in case you want to like do frame by frame and read what they actually put here, but it's a really long description that I don't think is useful to actually read through. So like I said, if you want to see what they actually wrote here, go ahead and pause it with each of these frames, and you can read what they're saying. Okay. Let's get to the bottom here. I guess one more thing they say in here is constants. So normally in constants in programming, they'll be in all caps. And what a constant is, it's like, for example, here they're going to have minutes and hours. Okay, so that's something that's going to be the same every single time. It's not going to change in your code. So for that, and they also have every ruble for a dollar is, I guess, 67.01. So you'll notice that if it's going to always be this weird number 67.01, you can assign that to a constant, and you should make that constant in all capital letters. Okay, and that's kind of the end of their description here. And so now they want us to write the function minutes to hours. It's going to convert minutes to hours. Pretty simple. So we'll go up here. We'll make the constant minutes in hour, and we'll assign that to 60 because there's 60 minutes in an hour. And then we come down here to this function, and we're going to return the minutes that they gave us divided by minutes in hour. So let's say, for instance, that they send 60 to this function. It's going to return 60 divided by 60, which is 1 hour. So you're turning that minutes into hours, okay? If they send us 120, we're doing 120 divided by 60, we get 2, which is 2 hours. And so that should be the solution for this. Let's play it and see if we get what we expect. Okay, that seems about right, so we'll check it. Correct. Okay, next. Functions are as a code organizing tool. Even if you don't plan on reusing a piece of code, it's best to include it in a function anyway. This technique will allow your program to be broken down into named blocks, which will make it easier to become oriented with it. Now that we've gained this knowledge, let's return to the analysis of our set of films. One of the crucial commercial features of a film is its return on investment, or ROI. A film's ROI shows the revenues that have been generated by every dollar invested in that film. ROI is calculated by using the following equation. Let's write a function that will calculate the ROI of every Oscar-winning film. Now let's put our function and use it to figure out which films turned out to be the most profitable investments. As you can see, the most profitable films weren't the ones with the largest box office gross. Okay, so now let's calculate the per minute cost for each film. In order to do this, write the function add cost per minute. It should add the value it calculates as a new column. The function should accept a single argument, the data table. This is the table that the function will then change. We have already written the code for printing output on the screen, complete it by including the following equation. Okay, so if we scroll down, this is the big table that we've seen previously. Okay, so cost per minute in the data table is going to be the budget divided by the length. So let's first get the budget, which is going to be equal to, I guess they want us to iterate through the data, right? So 4 elements in, and we're going to be changing the elements. So we should use the indexer one, which is for index in range 0 to length of data. We're going to grab the budget, which is going to be equal to the so this is doing data at index is going to give us the whole one of these lists. It's going to give us like one of these, and so from there we need to pull the budget, which we see is which column. Let's see if we can see if they give that to us up here potentially. So it looks like the budget here is going to be number 5, just from stealing it from their code. So we're in this list, right? One of the lists in the lists. One of the lists in the list of lists. That's a mouthful, but then we get number 5. That's going to be the budget, and then we also need the length it has here. So we do length is going to be equal to data at index at. So we need to figure out what the length index is now. I wish they would just give it to us, because that's like annoying to actually. So this is year, this is rating, this is, what is the 4th row? 0, 1, 2, 3, well 3 index. Well, I guess we can assume that it's the one that's not already used in their code. So let's go to their add ROI function. Wow, this is just gross the way they set this up. Okay, so if gross is 6, it'd be 0, 1, 2, 3, 4, 5, 6. That means that this one has to be the length, which is 0, 1, 2, 3, right? Okay, and so now they want us to add the cost per minute column. The way we do that is data at so the one list in the table dot append budget divided by length. Okay, and then they want us to return nope, I guess since it's global, we don't even have to return it. We can just leave it the way it is. And then, so let's play it, see what we get. Okay, let's see if that's right. Correct. All right, next. We'll take a closer look at how the Academy's preference has changed over time. In order to do that, we'll need to instruct Python how to differentiate new and old films apart from one another. Here we can use a conditional statement to our advantage. It will allow us to create forks, that is to set a condition and follow one code given one outcome and other codes given other outcomes. Let's write a function to check whether or not a film has won an Oscar for Best Picture in the last 10 years. Okay, so they have this new thing called an if statement. If year is less than 2008, then it's an old film. Otherwise, which is this else statement, print new film, okay? see if I can... Okay, the keywords if and else join forces to make a conditional statement. If the condition in question is met, then Python will complete one section of code. If not, it will complete a different section of code. This template shows the general syntax of a conditional statement. So you can see the less than sign is a condition, and after you do the colon, that's when your action starts. That's going to happen if that condition is correct. Okay. For Python, conditional statements are like a fork in the road at which a decision must be made as to which code to take, the left or the right. At every check if recent function, Python will encounter that fork and make a decision. The symbol less than in our condition correlates with the mathematical less than symbol. This table displays similar relationships to other mathematical symbols. So you can do less than or equal to, greater than or equal to, less than, greater than, equal to, or not equal to. So you see the difference here is for assignment in languages, you do one equal sign. To check if two things are equal, you use two equal signs, okay? And the not equal, you use an exclamation point in front of it. That should be the only weird things there. In order to remember whether it's less than or equal than or less than, I've never seen this before, make a note that the symbol order is the same as in the description, less than or equal to, not equal to or less than, okay? Write the function check if long that will determine whether or not a film is lengthy. We'll consider any film less than 2 hours as short and everything else as long. This function should accept the length of a film as an input, then input either long film or short film. Okay, so they want us to come here and we do if the length is less than, what they say, 2 hours. So that's going to be... So potentially you could have a global variable up there that again does hours to minutes or minutes to hours, but we'll just do for ease of shortness in code, I guess, we can do length times, or I guess length divided by 60. What am I doing here? Okay, if length is less than 60 times 2, right? So you have... They're going to give us the length in minutes, right? That's why they have 96 and 155 here. And 2 hours is going to be, I guess we could just put 120 here. But that's basically 60 times 2 is 2 hours, you know. Actually, it's useful even if you're programming to just put a comment here. 120 is 2 hours in minutes. Okay, and like I said, you could assign that to a constant, and that probably is the better way to do it. Okay, so if the length is less than 120, we print short, right? Short film. Period. Otherwise, we use else statement, print long film. Okay, so let's play that and see if that's right. Okay, check it. Correct. Next. Table filtering. Conditional statements open up a new realm of possibilities. For instance, they help us filter tables, meaning either to remove or keep elements based upon a specified predetermined rule. Let us write a function to filter the table according to years. It will accept the year as an argument and return a new table with films that have received the award that year as well as following years. For example, if we want to input the year 2010, then we should receive a table that has only dates from 2010 to 2017. Okay, so they have the table here initialized again. Okay, and then they have this new filter or new function called filter after. They take in the data, which is the table, and they take in the year threshold, which is, you know, at what point you should start adding movies if it's within that year range. And they iterate through each row in the data, so they're grabbing each of the films basically, and they're grabbing the first element, which is the title. I mean, the title is 0 index. The first title is the year. Okay, so they have the year assigned here, and then if the year is greater than the year threshold, they're going to add it to the resulting table, and they return it. Okay, so then they print the table. That should be what we've done before. Okay, is that all they have for this? Yep, that looks like it's the bottom. So, okay, so we're going to filter this table, keeping film from the years 2000 and later, and then sort it in descending order by box office gross and print the top 5 results. Okay, so here they have the table initialized again. Okay, so they had the year threshold. Okay, so they want us to call these functions that they've already set up for us. So we're going to do print, or not even print, we just do uh, filtered movies is going to be equal to filter after. We send it the same data. I think it's actually called Oscar data, right? Yeah, so we should be sending Oscar data. And the year we want it after is 2000. Okay, so now we have a new table, and I'll just print that so you guys can see what we have now. Okay, so you can see 2017 is in there because that's after 2000. Moonlight's in there because it's 2016. We'll just go to the end to see where it actually stops at. The Departed 2006. (2003). Gladiator 2000. So this should be the last one. Let's make sure. Yep, that's the last one. Okay, so we've basically filtered it down from, they had movies that were from, 1990 here, right? So those are no longer in the list, right? We filtered those out through this function they created for us up here. Okay, and now they want us to take the result and sort it in descending order. So the way we do that is we do filtered movies dot sort. And if you remember, this is a list of lists, so we have to use the lambda statement to sort it. Lambda row, and then we're going to sort by the box office gross. And so the box office gross is which row? Looks like 0 is the title, 1 is the year, 2 is the rating, 3 is the length, 4 is the budget, 5 is the box office gross. So we want to do it by index 5. And we want it to be in descending order, so we do reverse equals true. Okay, so that should take care of that sorting. And then now we want to print the top 5 by column. Print underscore top 5 by column. Oh, you know what? They already do the sorting for us in this function too. So we literally only have to call these 2 functions. That's kind of nice that they already made for us. Not a lot of learning going on here, just calling functions, but so if we send it filtered movies, and we're doing it on column 5, which is the gross, and then reverse is true. Okay, so let's play that and see what we get. Okay, so we have 2000, 2006, so it's not sorted by year, which is fine. We want to sort by box office gross. So you see box office gross is 457. Is there another column at the end here? Year, rating, length, budget, box office gross, Year, rating, length, budget, box office. So that looks wrong, right? It should be 1119 should be ahead of that. Okay. The row column, print top 5 by column. It's grabbing row at column. So if we do Okay, 0. Oop. 0 is the title, 1 is the year, 2 is the rating, 3 is the length, 4 is the budget, 5 is the box office gross. I'm confused why that's not sorting correctly. It's almost like their function is wrong. What if we do 4 here? Oh, you know what? They have row 0 through 6 over here. What is 6? Because I think box office gross is the last one, right? So we have 0, 1, 2, 3. Oh. 0, 1, 2, 3, 4, 5. Yeah, so they only have 5 elements. Why are they doing 6? Their code is weird, guys. I'm gonna change this back to 5 and see if they count it as correct. I think they're just printing it weird. I don't understand. Check it. That's what I thought. It's wrong output. It's just So I had to take a closer look here now, and I went back up to the data, which is up here, and you can see 0 is the title, 1 is the year, 2 is the rating, 3 is the length, 4 is a category, and so that was what was screwing me up. Is in their table they don't have anything. They actually don't include this list. And so 5 is, I'm not sure what this number is, but 6 is the box office gross, right? So we were using 5 before, and that's why it was acting weird. So if we come down here and look in their function, they're doing row 0, row 1, row 2, row 3. They don't have row 4. Then they have row 5 and row 6. So we actually want to sort by as 6. So I put the column 6 here, and so when I play that, we get this description, which does have the box office gross going down now. Okay, so that should be correct. Let's check. Correct. Okay, next. Okay, write a function to filter the films by length. It should single out films that are lengthier than the input value. The function should have 2 input arguments, the table and the specified running time. It should return a new table instead of changing the original. In the new table, you must only include films that are under 2 hours long and sort them by box office gross. Okay, so filter not longer than. Okay, so if we do, let's see if they have. Okay. So they want us to run through and make it. First of all, they want to make a new list. We'll call it filtered, and we'll make it equal to an empty list. Okay, and then they want us to iterate through the column or the list or the tables we have. So we'll do 4 elements in data. We don't need to use the accessor because we're not changing this data. We're just making a new one. And we'll say the length is going to be equal to element at, let's see which one the length is. 0 is the title, 1 is the year, 2 is the rating, 3 is the length, I think, at element 3. And if the length is less than, let's see, 2 hours long, so we should do 120 here. Then we will append this element to the filtered list. Filter.append element. Oh. Okay, and then sort them by box office gross and print them. So it looks like we built this function. We need to return the filtered list now. which we'll do after we iterate through all of the list. And so here we'll call that function that we just made, which is filter not longer than. Oh, and we shouldn't use 120 here. We should use the variable we send, which is length threshold. Okay, scroll down here, paste. The length threshold, as we said, is 2 hours, but it's in minutes, so we do 120. And the data is actually called Oscar data. Okay, so we called that function. We're going to get the let's call this variable less than 120. Scroll over, press enter, and then we're going to print top 5 by column. Our data is this less than 120, and the column we're going to sort by is the box office gross, which last time we found out was 6, and then the reverse, I guess, is true as well. So we'll play that, see what we get. So we see these lengths are all under 120, and we see they're sorted by box office gross for 14 going down. Okay, so we'll check that. Interesting. Do they want us to do less than or equal to? Guess that's what it is. They should make that clear over here too, because they don't really say that. So this video is getting kind of long, so I'll just stop it here, and we'll pick this up where we left off next time.